We start the next topic for chapter 2, and that is ions and ionic compounds and their formula. Unit 3. This is a pretty long slide. It has a large number of PowerPoints on it, but towards the end, you have review self-study questions. Please go through it so that you understand what it all entails, and you are able to explain everything that is there and make sure that you understand and you are able to write the formula of the compounds. It is very, very important that you know how to write the formula of the compound so that in the future chapters, when you have to write the formula, you become familiarized with it. Remember, you're not going to get it in one day, but practice makes perfection. So the unit 3 for chapter number 2 is ions and ionic compounds. Ions, you have to recognize that metals atoms commonly lose one or more electrons to form positive ions called as cations. Non-metals often gain electrons to form anions. In order to predict the charge on monoatomic cations and anions, it's based on the group number from the representative elements, that is group 1A, 2A, and so on. Every compound tries to form or acquire or lose electrons in such a way that the total maximum number of electrons available on the outermost shell is 8. That's the whole purpose. And name and write the formula of ions. When writing the formula of ions, combining ions in the proper ratio to give a zero electrical charge, name and write the formulas of ionic compounds, understand the importance of Coulomb's law in chemistry, which describes the electrostatic forces of attraction and repulsion that is present. Now, these are the most important things that you have to know in this particular type of group assignment over here. Ionic compounds are generally combinations of metals and non-metals and constitute another major class of compounds. They consist of ions, that is atoms or groups of atoms that bear a positive or negative electric charge. Many familiar compounds are composed of ions. Table salt, for example, consists of sodium cation and chloride as the anion. These are generally referred to as salts, and you can see on the right-hand side how they are rearranged in a box with chlorine atom surrounding one sodium atom and one sodium atom surrounding 6 chlorine atoms. And so it just goes on repeating by itself. That is called as the unit cell. Now, some of the common ionic compounds, they may be also like gemstones. And so here are some common named compounds. Calcite, calcium carbonate, consists of calcium ion. The carbonate ion, the name of the compound is calcium carbonate. The formula is CaCO3. Fluoride, calcium fluoride, CaF2. The charge on the calcium ion is +2 because it belongs to group 2. Fluorine belongs to group 7, needs one more electron, so it gains an electron, so it becomes F-. Gypsum, calcium sulfate, dihydrate. So calcium sulfate, and there is a dot in between indicating that the water molecule is in between the two compounds, and there are 2 water molecules. Therefore, we name it as dihydrate. Calcium 2+ and SO4 2-. Hematite, iron oxide, Fe2O3, Fe3+, and O2-. Orpiment, arsenic sulfide, As2S3, As is 3+, S is 2 minus. Now, when I'm reading it, it looks so difficult, and you must be wondering how these charges and of these compounds are obtained. And there is a very, very simple way, and we go and do it. And by practicing, you'll understand how to do it, because everything is based on the position of the element on the periodic table. Ions are atoms or groups of atoms form positive or negative ions. Removing electrons from an atom produces a cation. That means an element with a positive charge. A cation is fully named. When writing the formula of the compound, a cation is fully named. Adding electrons to an atom forms an anion, and it has a negative charge. And the name of the anion is changed by dropping the last few letters of the element and adding IDE. You can see the example of how magnesium forms a cation. And now where do we get the +2 from? Because it lost 2 electrons, magnesium on the left-hand side has 12 electrons, 12 protons. But when it loses 2 electrons, the number of positive charges is greater by 2, and therefore you write it as Mg2+. In the same way, when an anion forms, it gains 1 or more electrons. 1 or more electrons. And so you can see that here, fluorine has got 9 protons, but when it gains an electron, it will have the neutral fluorine has 9 electrons and 9 protons. But when it gains an electron, then we write it as F minus, indicating that it gained an electron. In general, metals lose electrons, forming cations. Non-metals gain electrons, forming anion. So we can have the question, how many electrons? So group 1 elements lose 1 electron. Group 2 elements will lose 2 electrons. Group 3 elements will lose 3 electrons. Sometimes when you go to group 4 at the bottom, because they're pretty heavy, they may lose electrons that are there. On the other side, we have group 5 gains 3 electrons to form 5 plus 3 will form 8. 6 elements in 6. Group 6, they gain 2 electrons. Elements in 7 gain 1 electron. How can we calculate how many electrons are gained? For anions, you just say the charge on the new charge on the anion will be the group number minus 8. So whatever the extra minus is, it is associated with the particular element. And so here you can see how you can get, by losing and gaining electrons, how we can have the atom has the same number as the nearest noble gas atom. So every element, when it loses or gains electron, it tries to get the structure of the nearest noble gas atom, because that is very inactive. Naming monoatomic ions. Cation, name of the element followed by the ion word. Anion, you name of the element, change it to IDE, and then add an ion, ION word, terminal. Main group elements. All metal cations are named after their respective elements followed by the word ion. So sodium lost 1 electron, sodium ion. Barium lost 2 electrons, barium ion. Aluminum lost 3 electrons, and it is called as the aluminum ion. The transition metals generally, and they are the middle B group elements. Here you will have to write how many electrons are lost, and the write-up is in parentheses, and we write the Roman letter 1, 2, 3, so that we can easily understand and identify uniquely the metal cation that is there. Cu plus means it is copper 1 ion. Cu plus 2 plus means it is copper 2 ion. The nonmetals end in IDE suffix, And so we can see nitrogen becomes nitride, oxide becomes oxide, fluorine becomes fluoride, phosphorus becomes phosphide, sulfur becomes sulfide, chlorine becomes chloride, selenium, Se, becomes selenide, and bromine becomes bromide. Tellurium becomes telluride. And so you can see that by dropping a few letters, we add IDE, and then we get the name of the anion. Now, polyatomic ions, a special class of ions where a group of atoms tend to stay together as an ion that contain atoms covalently bound together. Polyatomic ions, anions are groups of atoms, molecules with a net charge. So both of them, they tend to be together and they have charges associated with it. The various polyatomic ions, many of them contain oxygen, and because they have many oxygen atoms at different numbers, we have to be able to identify by writing ITE, that means it has less oxygen, ATE means more oxygen, then we have hypo, which means still further lesser oxygen, and per means much more greater oxygen than the 8. So hypo means less than the 8, and 8 means greater than the, per means greater than the 8 ion. That is there. Ionic compounds are neutral. Amount of charge, positive charge, must be equal to the amount of negative charge, that is the ion charge of main group elements, is predictable. So 1 to 3 lose electrons, 5 to 7 gain electrons. When writing ionic formulas, metal cation combining with a non-metal anion, the total charge must be equal to 0. That means the positive charge must be equal to the negative charge. And ion charges are always predicted by using the periodic table, because the location of the element will tell you what charge, how many electrons will be gained or lost. However, when we come to transition metal cations, these elements may have more than one charge state. And therefore, we have to find the oxidation number. The charge is found from the formula. When we write FeCl2, that means we have to cross-multiply the charge at the bottom. The subscript for chlorine goes to the superscript for iron. Chlorine has -1 charge, so there are 2 times -1 is 2 negative charges, so Fe must be +2. Same way for chlorine. In FeCl3, we find that there are 3 chloride ions, but chloride ion has a negative charge. So 3 times -1 is -3. And therefore, in order for the compound to be neutral charge or net zero charge, we will have the formula as FeCl3. When writing chemical formulas, give individual ions the rule. Use crossover rule to make sure that the overall charge is 0. This applies to monoatomic ions as well as polyatomic ions. With polyatomic ions, you use the parenthesis as needed so that it becomes easy to write the charges and balance the equation formula charge very quickly. And here the cross-multiplying rule. So the sulfur, in the how to write the formula of sodium sulfide. Sodium has +2 and it combines with S sulfur, which has a -2 charge. So what we do is we take the positive charge of sodium, which is 1, and write it for sulfur, cross-multiply it. And the negative charge of the number 2 goes to sodium. So the charges are not written, but only the numbers are transferred. So when writing, write a formula for these compounds like sodium and bromine, sodium, oxygen, aluminum chlorine, barium chlorine, aluminum oxygen, magnesium oxygen. Just go to the periodic table and look at the position of each of these elements and then find out what the charges would be. You can go right up onto the top of the this presentation. You will find the charges over there, and then you can write the correct formula. And again, some more, when we are using polyatomic ions, the polyatomic ions are given in a tabular form with their charge. Remember, put the polyatomic ion. Now, which of these are polyatomic ions in this formula? The sulfate, hydroxide, acetate, and nitrate. They are all polyatomic ions. So first thing to do is write the formula of the polyatomic ion, put them in parentheses, and then give the charge. Once you give the charge, then you check the charge for the cation element, metal ion, and then cross multiply as usual to get the formula of the compound. The formula properties of the ionic compounds. A metal atom can transfer an electron to a nonmetal atom. The resulting cation and anion are attracted to each other by electrostatic forces, as shown in the formation of lithium fluoride. Remember that the atoms just touch each other, and basically we can see when the lithium atom touches the fluoride atom is bigger. The lithium atom, because it lost its electron, is smaller. And the distance between the two atoms is the sum of the radii of the two atoms that are there. And therefore, the electrostatic force of attraction based on Coulomb's law states that the charge force is equal to minus K, which is a proportionality constant. N plus and N minus are the number of ions or valence charges that is there and charge on an electron. The force depends directly on the charges of the ions and inversely on the distance between them. The oppositely charged ions in ion compounds are attracted to one another by electrostatic forces, and these forces are governed by the Coulomb's law, which is given above. So now, this will always help us. This particular law tells us which compound will be attracted to a larger and greater extent as compared to the others. So here we see how the Coulomb's law is applied. In the first case, you have the lithium ion showing up, and the second one is for two different compounds that are there. And how do you understand the distance and the Coulombic law forces? You can see that in the distance between lithium and fluorine is much smaller as compared to the elements that have the larger size and a higher charge. But that is there. So when the distance increases, the force of attraction decreases. As the ionic charge increases, the force of attraction decreases. And this is a rule that comes directly from the expression for the Coulomb's law. So higher the charge, greater the force of attraction. Lower the charge, smaller the distance, stronger the force of attraction. That is. Now, this is the effect of Coulomb's law, and you can see it. Sodium and chloride form sodium chloride, and you can see how the crystal structure is. And this cell is expanded in order to show you where the sodium ions are located and how they are surrounded by different elements. And on the right-hand side, you have magnesium oxide, which consists of magnesium metal and oxygen. Now, you see that sodium is +1, chlorine is -1, and its melting point is only 804 degrees Celsius. But in magnesium oxide, the charge is +2 and the oxide is -2. And look at the melting point, how strong the bond is, because the smaller distance, how strong the bond is. And you see that the melting point goes up to 2,800 degrees Celsius. So magnesium oxide with a greater charge and smaller bond distance has a higher melting point as compared to sodium chloride. Then naming the ionic compounds. In naming the ionic compounds, the rule is always name the cation first, the anion is named second. A monoatomic cation takes its name from the name of the element. A monoatomic anion is named by taking the root of the element name and adding IDE to it. So you can practice over here. A series of compounds is given. I'm going to give you one example, and that's the last one. How would you name it? Because all others, I'm sure you will be able to name it. Now, in the last one, the formula is Mg3N2. Remember, in molecular compounds, we would write the number of atoms of each of the elements present. But here, we don't do that. What we do is we write magnesium nitride. So we don't tell how many atoms of magnesium is there, how many atoms of nitrogen is there. We just call it magnesium is the cation, and we say magnesium, and nitrogen is the anion, and we say it as nitrate. Now, why do we say that? Because the compound is neutral. How do we know the compound is neutral? Magnesium belongs to group 2. So it loses 2 electrons. So 3 times plus 2 is plus 6. Nitrogen, on the other hand, belongs to group 5. 5 take away 8 is negative 3. So it has a negative 3 charge. Negative 3 times 2 is negative 6. So plus 6 minus 6 equals 0. And that's how we determine the neutral compound. When naming transition binary compounds, these metals can often have more than one charge. In that case, we use numeral numbers to indicate the charge. For example, chromium plus 3 is written as chromium in parentheses, Roman number 3. Chromium plus 6 is written as chromium in parentheses 6. That is V1 and 111. Naming a transition compound. So because they have different possible charges, again, we use the charge on each of the ions, and when we write the compound, the metal is written fully, iron, and then we write the charge in Roman letters and end it with an oxide. Again, this is for practice. Practice for you so that you can understand how to name. Okay, just let me see. Now, from below this, almost everything will be practice self-study. So review all of this to see whether you have understood the concepts that are included in this particular study session. And with that, I'm going to close this particular unit.